see. You'd have the setting sun, setting below, in this case, the blue horizon, and there's a little bit of a green tinge at the top, and it would just go boom, and there'd be a little bit of green there, but really not much. Let's do that again. Boy, it sure doesn't last long. There's a little green tinge up here, see that? And that's the last part to go down, so you would see it right there, a bit of green. But boy, that's a pretty fleeting effect. You know, that didn't last very long. You'd never notice the green flash if that were all there is to it. So there's got to be something more. And it turns out that the extra factor is mirages. The sun's light gets miraged. Let me explain what I mean. Here's a sequence of photographs of the setting sun. And you can see it's highly distorted by different amounts of bending by different layers in the atmosphere. Layers having different temperatures and different densities and stuff. So here's a bit of the sun broken off, and here it's all distorted. And then you're looking at the top of the sun here, and it's almost like the top is breaking off. Look at that, part of the sun broke off. Holy cow, what happened there? Well, you know, a physical part of the sun didn't break off. You know, the sun didn't bifurcate into two or anything like that. What happened is there was a mirage. And under exceptional circumstances, the top part of the mirage can be this green button, this green top of the sun that gets lifted above the rest of it, and causing it to be visible for a slightly longer amount of time than you would otherwise have predicted. So let's consider the two main kinds of mirages. The first is called the inferior mirage. That's what happens when you have hot ground heating up the air just above it with a cool, denser layer of air above that. In that case, an incoming light ray gets bent toward the denser, cooler air. So it gets bent in this direction, sort of concave up. And it enters your eye like so. Now your eye and your brain don't know that it was bent. All they know is the direction along which the light entered your eye. So your eye thinks that the light came from over here. And what you see is an image of the blue sky. And that's what forms the familiar lake or ocean mirage that wanderers in the desert, you know, they see this lake in front of them and they go, ah, an oasis, we've been saved, you know. Well, unfortunately for them, it's just a mirage. And as they get closer and closer to it, the thing remains at the same distance because it's just an illusion. It's a mirage, all right? There's another type of mirage called the superior mirage, and that happens when you have cold, dense air near the ground, or near the ocean is often the case, with hotter, less dense air above. In that case, if you have an object down here, light rays will get bent like this, causing the eye to see the object as being higher than its true position on Earth, or above the Earth. And the rays that start from higher up are bent less than the rays that start from lower down because there's this change in the density of the air. The coldest, densest air, the kind that can cause the most bending, is closest to the ocean. And if the light ray starts from well above that, it doesn't get bent as much. So that light ray doesn't enter your eye at as steep an angle. So what you get is an inverted image of your object. It's a fantastic phenomenon. Here's an example of it. Here's this ship on the ocean, and you can see the true image of the ship, but also the inverted mirage image. Look at that. The bottom of the ship is now at the top. It's incredible. In fact, here's an actual video taken by Pekka Parviainen in Finland of a ship cruising by, and it's like a double-decker. It's fantastic. There's the image of the ship as it would normally appear, but then there are rays of light that get refracted or bent like this, causing an inverted image of the same ship above the other image. And the top of the ship is above this layer of cold and dense air, and so it didn't get miraged at all. So that's really a fantastic thing. Mirages are fun to look for, okay? So now let's apply what we know about mirages to the setting sun and see how it helps make a more enhanced green flash. Here is the sun setting with this refraction taken into account and the mirages taken into account. So notice how the sun got distorted on its way down, and now a little bit gets lifted up and hovers above the horizon for a longer time than would have been the case had there been no mirage. You can tell there are mirages going on because the sun is all distorted. So now the top of the sun breaks off, and it's that green piece of the sun that hovers above the horizon for an extra few seconds, allowing you to see the green flash. Here's another animation showing a different temperature and density structure in the atmosphere of the Earth. So now the mirages that you see differ in detail from the ones in the previous animation, and still you can see that there's a bit of the sun hovering above the horizon, detached from the rest of the sun, and that part of the sun is that little green button that I was talking about, enhanced a little bit. Look at that, boom, it looked green. So here's an actual video, again taken by Pekka Parviainen, of the setting sun in real time. And you can see that the different layers of air in the atmosphere have tremendously distorted the shape of the sun. But the basic idea is that a little part near the top gets detached, and that detached part is that little green button that I showed you in the diagram, and then it fades away. So it's just a marvelous effect. It's hard to see. Not many people have seen the green flash. In fact, a lot of people think that it's sort of a myth, but it's not a myth. You really can see it. And then some people think that, oh, it's some sort of a physiological effect. The sun is red at sunset, and if you look away from the sun, the complementary color is green, so that's what you see. Well, yes, that is what you see if you stare at a red sun and then look away, but that's not the cause of the green flash. You really can see the green flash for real if you have proper conditions. In fact, if conditions are really good and the sky is exceptionally clear and you don't have much dust in the air, then you can even see a blue flash. So here's a sequence of 4 images of the sun as it's getting lower and lower, and you can see in that last image the sun actually looks blue, not green. And that's because this image was taken when the atmosphere was so clear that there was very little particulate matter absorbing the blue rays. So in that case, there was a tiny fraction of the sun that looked blue. At the very top of the green image, you could actually see the blue image, and that was the last one to disappear. Now you can see this really well sometimes during sunrise, because during the course of the night, a lot of the particles settled out of the atmosphere and things kind of became stable, and all the junk that normally fills the atmosphere during the day got filtered out. So I've seen one blue flash at sunrise, and it was a marvelous experience. By the way, if you observe the green flash at sunrise, you know that it's not a physiological effect because the first bit of the sun that you see is the blue or green part. It couldn't have been a physiological afterglow of having seen a previously red sunset. Okay, well, when should you look for the green flash? It's of paramount importance to have a very nice, true low horizon. No mountains, no trees, no buildings, because those sorts of objects form a false horizon. When something is setting on top of a building, it's not really setting below the Earth's surface. It's just a false horizon, so you don't get much bending of light and you don't get the green flash. You also need conditions to be very clear. Very few clouds at the position of the sun, of course, and very little particulate matter, not much dust and smog, okay? That's when you see the green flash. So you don't want to be looking at the sun when it looks deep orange or blood red like this, because all the blues and greens have been filtered out. Even the yellows have been filtered out. You want to look at the sun when it looks yellow or white. That means there's not many particles in the sky. And part of the sun can be blocked as long as the part above the horizon is clear. Then you can see a green flash just as it's setting. When you're monitoring the sun just before sunset, be very careful. Don't stare at the sun. Never stare at the sun, especially when it's high in the sky. It's better not to stare at it even when it's pretty low, because it can burn your eyes, okay? Maybe take a glance at it every once in a while. Every 10 or 20 seconds, glance at it to make sure that you haven't missed sunset, and then look away. That'll also help save your eyes. Your eyes get desensitized if you stare at the sun, and then you won't see the green flashes easily. Or you could take a piece of filtered glass like this and look at the sun every once in a while. This is shade 14 welder's glass. You can get it in welding stores. And if you look at the sun through this, that is a safe way of monitoring its progress. And then maybe 10 seconds or so before sunset itself, then you can start looking at the sun more continuously and looking for the green flash. Okay, well, another phenomenon that you see around the time of sunset is called sun rays, or Buddha's rays, or crepuscular rays. And here's an example. Here's a cloud bank, and the sun is behind the cloud bank, and it's getting close to sunset, but you see all these apparently diverging rays of sunlight with dark bands in between. Here they're pointing down, but you can also have the sun below the clouds, and these diverging rays basically point up. So the sun is right down there somewhere. These are called sun rays, or crepuscular rays. Crepuscular means twilight, or like twilight, dim and hazy. The rays are seen most easily around twilight when the atmosphere is becoming pretty dark already, because there's not much sunlight hitting the atmosphere. So the sky is getting pretty dark, but along some directions, sunlight hits the atmosphere. Those directions that are not blocked by clouds are still being hit by the sun. If there are clouds in the way, well, those clouds produce shadows. So some parts of the atmosphere are in the shadow of the clouds. Other parts are still being illuminated by the sun. And the contrast is what forms these rays. They appear to fan out because the rays are coming in nearly parallel. They only appear to be fanning out because of a perspective effect, the vanishing point. Okay, this is something very familiar. If you look at sunlight streaming through a forest filled with smoke from campfires, here it is, and the light rays are coming in intrinsically parallel, but they appear to fan out, diverge from the sun because of this perspective effect, the vanishing point. And you can see this very nicely if you look in a hallway like this and see all the intrinsically parallel edges of the roof or the sidewalk here converging at a distance. Another example, of course, is if you're on railroad tracks. They converge if you look far away. So here we see these sun rays apparently diverging from their convergence point, but really they're coming in parallel into the Earth's atmosphere, and they only appear to diverge because of this perspective effect. Now you can see the sun rays even when the sun is very close to or even below the horizon. If you have clouds near the horizon and the sun is below them, then some of the clouds block the rays, and so you get a shadow. Other places where there are gaps between the clouds allow the sun's rays to hit this darkening sky. And so you get this effect of the rays fanning out from a hidden sun because of the shadowing effect of the clouds. And here it's kind of a bit hard to see, but very faintly you can see these sun rays fanning out from below the horizon. The sun's actually below the horizon, and there must be clouds below the horizon that are blocking selectively some paths and allowing other sun rays to filter through. And so that's a beautiful effect. Now, in some cases, you can even see rays on the opposite side of the sky. These are called the antisolar crepuscular rays, and they are just the rays that you would see in the opposite direction to the sun. So just turn around and look at the place opposite sunset, and you will see these rays converging. They converge for the very same reason that if you're standing on a railroad track and look in one direction, the railroad track converges to a vanishing point. Then turn around and look at the opposite direction, the rays or the railroad tracks converge in the very same way. So these parallel streams of light are going through the atmosphere, emanating from the sun, apparently diverging and then converging on the opposite part of the sky. And finally, when you're looking at these phenomena, you can sometimes see a dark blue band just above the horizon. That's actually the Earth's shadow. The Earth is shadowing part of the atmosphere. Here you can see it nicely at Lick Observatory. Above the shadow, these parts of the atmosphere still see a little bit of sunlight. But those parts there are already in the Earth's shadow. And as sunset progresses, the shadow grows more and more and looms above you, and twilight starts when the whole shadow envelops you. And at that point, the planets and stars begin to come out, and it's time to start observing the night sky.